Alright, so stars go through these stages where, let's see if I can go to it, like this. Kind of starts off like that, and then it either becomes a big star or an average star, like our sun. Our sun is one of theirs. So let's go with our sun. One day, our sun is going to eat up all the stuff around it and get big and become a red giant. When that happens, it's going to eat Mercury, it's going to eat Venus, it's going to eat Earth, and it's going to eat Mars.
How come it's going to eat everything?
It's going to get bigger, and it's going to take it in.
Will we all be dead?
By then?
Yeah.
Don't worry about it. It's not your problem right now. When that happens, it's a red giant. So it goes through all these stages, da-da-da-da. Eventually, it's going to have gas around it, and then it's going to have a little star in the middle.
Earth.
And then star. Oh, this is just stars right now. This is any star. Any star you look at the sky will go through either this one or this one. So, some stars become big stars, and then they become red giants, and then they explode. But they don't do that.
Kind of like comets?
Yeah, kind of like comets. But some of them implode. So if you take all this stuff, this table, you, all, me, Greg, all this stuff, you cram it into a little space, what happens? Gravity is keeping us on the Earth. There's so much of it, that nothing can get out, and it appears like a black hole in the sky.
But Earth doesn't.
You don't need to see it.
Earth only has this much of gravity, probably. It doesn't have
compared
that much effect.
Compared to like what?
Earth.
Earth compared to Jupiter. If you're on Jupiter, you'd probably weigh like 400 pounds. But if you're on Mercury, you'd probably weigh like 5 pounds. It's all relative.
Black holes are some of the most elusive objects in the universe. They can form when a massive star collapses under its own weight. Because they are very dense, the gravitational pull of black holes is so strong that nothing can escape, not even light. Thus they have long remained black and mysterious. But now, thanks to ESA's and NASA's X-ray observatories, XMM Newton and Chandra, astronomers have a much clearer picture of where black holes are and what they can actually do. And that can be quite dramatic. The gravitational pull of a massive black hole is enormous. If a star like our Sun happens to venture too close to such a monster, it can easily be stretched and torn apart. Differences in gravity acting on the front and back of the star eventually disrupt it. Like in an explosion, most of its gas, shown here in red, is ejected and manages to escape. But some of the gas is trapped by the gigantic pull of the black hole and slowly spirals in, forming a gas disk.